Kriti Gupta, and this is a presentation on my semester paper on the design and effectiveness of formative feedback in programming-based assignments. A lot of formative assessments are used in computer science that are programming-based, especially now with the MOOCs getting popular. The classes are much larger, a lot more TAs are needed, and a lot faster feedback is needed, so there is a need for automation. My research topic is on answering these questions. What is the effect of qualitative feedback on learning through programming-based assignments in CS? How can intelligent automated feedback be designed? And how is knowledge modeled and associated with the right feedback? So what is formative feedback? Feedback is traditionally used in management theory as a concept for iterative improvement. The earliest definition of feedback that I could find was by A. Ramprasad in his paper called On the Definition of Feedback, where he says feedback is information about the gap between the actual level and the reference level of a system parameter which is used to alter the gap in some way. Formative feedback is given regularly during the course of learning, unlike summative feedback, which is only given at the end as a form of score. I read in work from Koenig and Narkis on how feedback can be categorized based on types of knowledge. Some of them are knowledge on performance for a set of tasks, of a result or response of the correct results, knowledge about task constraints, concepts, mistakes, how to proceed, and metacognition. Formative feedback should be multidimensional, non-evaluative, so there should be more text than just a score, supportive, timely, it's even better if it is given very often while the student is learning, very specific, credible, infrequent, but genuine. There are different types of learners, as Sadler says in his paper, and knowing a student's learning style can help develop specific kinds of feedback and also improve the effectiveness of it. For example, there are movers and tinkerers. There are also non-starters. Movers are those that do not stop when they fail at solving a problem. They move on to a different solution quickly. Tinkerers, on the other hand, are those that would try random solutions when they fail. Movers could benefit a lot with formative feedback, and tinkerers could find more focus from intermediary qualitative feedback. Professor Carl Oliver suggests that software metrics can be used in formative feedback, like program size, functional correctness, efficiency, program style, and client validation. A few of these are already used quite popularly in assignments. I conducted a survey to gather opinions and information on qualitative and quantitative feedback from both teachers and students. Here I present you the results. For quantitative feedback, most of the respondents had encountered assignments with quantitative feedback, especially in MOOCs, and the majority of these assignments graded work based on accuracy instead of performance or quality. About 75% of the respondents found quantitative feedback at least a little helpful. Their opinions in terms of what was good about it was that they reported a sense of accomplishment when they were given a score. It was helpful to get immediate feedback instead of waiting for a TA to review. Quantitative feedback can be easy to automate. That would make grading a lot faster. People found scores objective and easy to understand where they stand, but they often did not find them useful when they did not do well. They found that instructor reviews could be subjective, but score-based feedback could be more objective by defining fine-grained tests. However, they also disliked score-based feedback because it gave them little clue on what went wrong. Sometimes it could be more discouraging than helping if you lose points on something small that is not even conceptual. While there is a possibility to test out a larger variety of test cases, the test could be too objective. That is, grade could be lots of minor errors where there was no partial credit and there was nobody to explain it to them. A majority of the people dislike the idea of the lack of feedback on efficiency and code quality. Often graders need to set the upper bound on running time, and it's set too high to accommodate for everyone's test to run. This leaves the students with no feedback on how close their solution was to a standard solution, even if they pass all the tests. Unfortunately, some people also mention that graders could be reverse engineered and thus made ineffective. But that is pretty much a problem of how grading is set. The effectiveness of the grader lies in the clarity of guidelines for grading and the coverage of test cases. Sorry, bad joke. Qualitative feedback. About 60% of the surveyed people had received some sort of qualitative feedback. Qualitative feedback is when you get some text, some more information that is not just point or grade based. Most students had encountered qualitative feedback in the courses from the OMSCS program, like Knowledge Based AI, Introduction to OS, Gradual Algorithms, and Reinforcement Learning. Some other universities were also reported to offer peer reviewed grades. Almost 40% people found qualitative feedback helpful in learning computer science concepts. They found it useful because it gave them a better direction on possible improvements. It covered more aspects of code quality than just a score on accuracy. It was a popular response that such feedback was often quite exhaustive and explained concepts than just grading the students. However, what was bad was that many people felt that written feedback was only as good as the person writing it. It could be too generic or could only be an instructor's opinion and not directly helpful in improving your work. Some other drawbacks I found were that the time it took for instructors to get back to students and the quality and grading scale was subjective and varying from person to person. So instead of receiving feedback at the end of the assignment, whether qualitative or quantitative, most of the people, more than 95% of them, preferred to get intermediary feedback and found that a lot more helpful. Educators' opinions. 48% of the TAs who responded to the survey did not use any tools for auto grading. Some others found continuous integration tools like Travis or Jenkins very helpful. Educators preferred to make their feedback effective by covering various aspects of student learning. They always wanted to add at least a pass or fail comment, and additionally they would also want to provide information on where the code was not working as expected without giving away secret tests. Some instructors identified areas of improvement within the code. Others suggested asking students what aspect of the code they wanted feedback on. They found giving a commentary on alternative approaches and encouragement when good choices were made a good way of giving feedback. Educators expect that some features of such rich feedback should be auto-generated. These would include code style suggestions and telling the student if the solution was not the standard or the best solution, even if it passes. Finally, I conclude that students and instructors both would want a lot more qualitative feedback. They express great trust and hope in automating qualitative feedback. The current work in the field can be extended much further by adapting auto-generated feedback to learner types, and I think there's still work to be done in learning the effect of various kinds of feedback on student learning with more experimentation. Thank you for watching. Bye.